Welcome back to another episode of Transmission. Today, we're exploring battery energy storage with Zach Vosburg, VP of Corporate Strategy at Flexgen. In this episode, Q and Zach discuss battery availability during critical market events, AI applications in energy storage, and why batteries are perfectly suited to solve what Zach calls 4-hour problems, not 24-hour problems. If you're enjoying Transmission, please leave a like and subscribe. Now, let's dive into the future of energy storage with Zach Vosburg.
Hey, Zach, welcome to the podcast.
Thanks for having me. I'm glad to be here.
Well, you're very welcome. So let's talk about Flexgen then. What's Flexgen about?
Well, Flexgen, we are a services and software provider to the battery storage space. We basically have kind of two sides of our business. The first up front is to provide per integration services, get batteries up and running. The second part of our business is to keep those batteries running at optimal performance, right? So fundamentally, Flexgen does two things. We turn batteries on and we keep batteries on the front end. That includes things like system engineering, procurement, commissioning, site design, getting that system up and running. And then once we reach commercial operation, our lifecycle services team will kind of take over. The HybridOS software runs those systems, and we provide remote monitoring, data and analytics, performance engineering, preventative and corrective maintenance, everything that's sort of necessary for keeping a battery storage site up and running.
All right. And is it just batteries that you do? Because I thought you did other renewables as well.
Well, I mean, we often work to integrate battery storage systems and co-located systems with storage, or we can do so with gas generators or wind. And ultimately, our EMS software is capable of performing energy management with all sorts of different combinations of hardware. But Flexgen is fundamentally a hardware agnostic company. We're a software first company that focuses on integrating every sort of combination of commercially viable energy storage and related, interconnected equipment. And our whole thesis is to stay hardware agnostic and use software to solve problems, and ultimately be customer obsessed through that part of the service offering, rather than as a manufacturer or a trading optimizer. Sometimes it's best to think about the things that Flexgen doesn't do to make sure to narrow it down a little bit. And we don't make anything, we don't make any batteries, and then we don't do the trading on the back end either. We just make sure that the folks that we work with have a optimally tuned system so that when you press the button, it goes.
Tell me a little bit about the business. How long has it been going? Where is it based? How many people are in the company? And some example customers.
Yeah, I would say Flexgen's been around for a little over 15 years now. So like in a battery storage market that is really quite nascent, in any real way that you would look at it, is probably really only a couple years old, right? But Flexgen has been around working on solutions in this space for 15 years, which sort of gives us a distinct advantage in having developed market leading software for managing these types of systems. We're currently about a 250 person company. We serve utility customers, IPPs, co-ops, any sort of eventual owner or operator of a battery storage system is a potential customer for Flexgen. And we contract with them in various ways, but really trying to be the convenient counterpart to make sure that any battery storage system can get up and running and stay highly available so that they can get the most out of those systems.
So if I was going to ask you about the challenges faced by battery developers or owners, it's all a bit silly at the moment because we're recording this on April 11th, and it's been a hell of a week in the markets. We've had tariff announcements and rollbacks and all sorts of stuff that are going to be incredibly disruptive to our sector, especially battery folks in the US. And I think it's fair to say there's not really much intelligent that we can talk about related to that because it's
No.
hyperbole.
I think you're right. We've certainly been doing some work over here over the last weeks trying to understand and scenario plan. And every time we plug something into the model and get through the analysis, something changes and we have to update it. And it's sort of a fool's errand at the moment because of the amount of constant change. But I think what gives me a lot of hope in all of this is ultimately that the value proposition of battery storage hasn't changed. In fact, it's probably getting stronger and stronger. And a lot of the market tailwinds that we had before these moments of uncertainty remain both, they're the same, but also maybe even stronger. While we come through this period of uncertainty, there'll be certain ups and downs, but I think that battery storage in itself sits in a really advantaged spot to continue to grow with all sorts of different use cases and applications. I think that the data center opportunity for batteries is enormous and a tailwind that will be prioritized by this administration and others, regardless of what's going on. So that's certainly an area of growth that we're excited about. And yeah, there will be uncertainty for a period of time, and that is undeniable. But we will power through, and at Flexgen, will, as we like to say, we will power on. So we'll keep moving forward.
And if you're listening to this episode, who knows what's happened between April 11th and
Yeah, and
this
now,
sound getting into your ears?
yeah,
Okay, before we get to some juicy topics like availability and collocation, Zach, I want to ask you about your role. So you're Vice President of Corporate Strategy at Flexgen. So what does a Vice President of Corporate Strategy do?
yeah, especially at a smaller 250 person company, I end up wearing quite a few different hats, I suppose. I have traditional responsibilities in kind of the corporate development setting where we evaluating strategic transactions, corporate partnerships. I worked closely with our partners to do our Series C a couple of years ago, and those types of activities. I'm also responsible for our sort of investor relations and work with our investor base, but also then all sorts of unique and special projects internally, sort of creating business plans for new service offerings. And one of the things that I did early in my tenure at FlexGen was sort of work on the business case for our lifecycle solutions business, which is the part that I discussed earlier, where we provide data and analytics, remote monitoring, performance engineering, all of the sort of commercial operation focused services to keep availability high. Sort of built out that business unit, kind of acted as the interim manager for a time before handing that off to a much more capable director that we've hired for that business. But yeah, so it really runs the gamut in terms of the things that I get to be a part of here at FlexGen. And it's never a boring day, and it's been a great switch from my previous life in investment banking.
All right. Now let's talk about availability, right? Because this is crucial to you guys. So battery availability is a massive topic and it's essential to participating in markets, especially in markets like ERCOT, where you've got to be online for a handful of days to make half your revenue, right? So can you talk through some of the causes of battery downtime that you think about a FlexGen, and what does best practice look like for owners and operators who are trying to figure out and mitigate these risks?
Yeah, I think that first and foremost, we think that it's important to have robust and capable software that can control those systems and keep them online to evaluate the various anomalies that might be detected in the system, that without trained and advanced software and good monitoring professionals might cause you to experience downtime because they take you offline, you wouldn't know what to do. But with FlexGen software, we'll be able to keep those systems online, and when certain anomalies rise to the level of needing a interaction, we have a trained remote operations center and a industry leading field team that will allow us to kind of detect the problem as it's happening, evaluate what we need to do, and then act on it quickly, regard whether that's a remote fix or rolling a truck and getting somebody out there quickly. The best thing is for the system to never go offline, and we think that hybrid OS software keeps those systems online quite well. But then, when something does happen and it requires some action, we try to complete that cycle of detecting, evaluate, and acting as quickly as possible to get those systems back up and running. And I think that having a partner that understands how to do that quickly is key.
So you mentioned hybrid OS there. Just if you could quickly give us a rundown of what that software actually does.
Yeah, hybrid OS is an energy management system, right? It sits at the center of the larger system. There is a battery management system on the battery itself. And everything sort of comes in through a central software system that is hybrid OS, whether it's the battery, the power converter, the inverter, the balance of plant equipment, the fire suppression systems, the signals from the grid for participating in grid services. All of those things kind of flow through a centralized software system that allows for you to respond in milliseconds to various signals and things that allow for that battery system to do what it's designed to do.
And so you mentioned earlier co-location, right? So if you've got, let's say you've got a solar site and a battery asset on one site, does your FlexOS software manage how all of that power is used on site, and the solar curve and the self consumption and then export to grid is all managed properly?
That's correct. Yeah, yeah. We have kind of call it the power plant controller in that instance, but it's part of the hybrid OS fleet of offerings, is to have that power plant controller that sits between that co-located asset and the battery, and sort of coordinate between, pushing the solar to the grid when it's needed, or storing it in the battery. And I think that this is a really key application, right? I mean, any single day that I choose to, jump on the KISO dashboards, you take a look through the Central Valley, and you're looking at negative prices through the middle of the day when the sun is shining, and you're like, what an opportunity. And then, you scroll further down those dashboards and see the curtailment that's happened in those areas over the last few days. And you say, what a waste of, a waste of energy that could have been put out onto the grid at a different time, but it had to be curtailed. And so I think that, we'll see more and more of this co-location, especially with renewables, allowing for the kind of the integration of renewables and addressing that intermittency, and making sure that we don't waste energy. We're not curtailing and blowing it off into the wind, as it may be.
Coming back to your job, Zach. So, as vice president of corporate strategy, and you mentioned that you lead on fundraising for the business.
Yeah.
So you must be out there pitching the vision of Flexgen a lot. So, what's the big, grand, bold vision for Flexgen? What does Flexgen look like in 10 years' time?
What we see at Flexgen is ultimately to prioritize the use of our software and service capabilities to be the energy management system that manages every single battery in the world, right? I think that we view ourselves as in a position to be the preeminent energy management software for the management of batteries and the other co-located assets that we've discussed. And ultimately, 10 years from now, there's certainly, an aspiration for Flexgen to be that energy management system that controls everything, right? I'm here on a Lenovo laptop, but being hardware agnostic, like Windows, Flexgen ultimately wants to be the same. Whether you bring a Lenovo, a Dell, an HP to the equation, we won't make the box, but we're going to make the box work. And that's really what we endeavor to do, is to be the convenient counterparty and the central point to make all of these incredible systems that OEMs and innovators are working so hard to change, and ultimately to make sure that they work, that they tie to the grid, and that we can make a harmonious connection between one generation of technology to the next. And that's why our hardware agnosticism is really quite important, and why we design our software and our service offering in that way.
All right. So, every battery in the world controlled by Flexgen one day.
Yeah,
So, let's switch lanes now. Let's talk about AI and optimization, because I know this is a topic that means a lot to you.
certainly.
Where to start with this? I mean, AI-driven optimization is just a massively growing topic for discussion. So, what are the real practical applications of AI right now in storage optimization, and where do you see the most impact in the future?
Yeah, I think that, we, like so many businesses, are trying to adopt AI workflows into as many areas of our business as possible, right? Everybody you talk to today is saying if you're not adopting AI, you're falling behind very quickly, and we certainly believe that, and are trying to adopt AI workflows into everything that we do. Some examples of what we do at FlexGen, kind of on the front end in the kind of integration phase, FlexGen uses AI tools to map the control languages between different OEMs and different for DC blocks and inverters, and how to make sure that the communication protocols between those devices are perfectly mapped. It used to be a very manual task, sitting down with the Modbus maps of those different pieces of hardware and mapping things with different names to one another, and making sure that open contactors here means open contactors with the other piece of equipment, and they're going to speak the same language. We now do that through an AI driven tool that will map those things together quite accurately and quickly, and our ability to integrate new OEM packages and combinations has been accelerated dramatically. Also, sort of in that front end turning batteries on phase that what I discussed earlier, we use AI workflows to automate various commissioning tasks, including things like our system testing and protocols that used to be done with a field technician with a Cat5 cable plugged into the battery storage system out in the field in 110 degrees, running that test. And now, we get the software installed quickly on that system, and we make a quick call or send a Slack message back to our remote operations center, and ask them to go run tests that can now be done fully remotely in an automated fashion. And that person that's sitting out there in the field doesn't have to run that whole test the entire time. They can do it in a more automated fashion. On the back end, once we reach commercial operation, I think that this is an area that we use AI pretty robustly, right? I think that our software is ingesting millions of data points every day. We use those data points to analyze, the preconditions to alerts and alarms and find ways to say, all right, we saw this alarm. What were the conditions that were present in the system before this? And using AI to say, all right, we can come up with some predictive analytics that allow us to see these conditions and make alerts before there are alerts, if you will, right? And that's really quite important. And of course, like as we see more and more things and we ingest more and more data, the AI models are able to identify more of these conditions. We're able to automate the workflows that allow us to react to those conditions. I think that, earlier I said something about detect, evaluate, and act, and that's sort of a circular workflow that we think about in many of these situations. Can we detect what's happening, evaluate what the plan needs to be, and then act on it? Right. And in the beginning, of course, that's a very manual task done by a remote operations engineer. But as we do it more and more, and as we work through standard operating procedures, we can use AI and automation to take those workflows and accelerate them so that that cycle of detecting, evaluating, and acting is much quicker.
So what are the real challenges for coming back to your power park controller, or there's loads of different names for this thing, right? Where you provide a system that brings together the different containers or mega packs or whatever, and the balance of plant and everything all in one system, which is a very difficult problem to solve because you have balancing issues to manage and SCADA and various other things. But one of the problems that many asset owners have is that sometimes when they press the button, so I've got a 50 megawatt asset and I need 50 megawatts of power, what they see at the meter, at the boundary meter to the outside world, often isn't 50 megawatts because of a complex system of losses and control issues and ramping and air conditioning load and auxiliary load and all these things that kind of add up and end up with this world where you don't get what you thought you were going to get, which is firstly, that's suboptimal because you may not make the money that you expected. But there's also a big in certain markets, there's a penalty risk there, right? Because you have to make up the difference from what you're obligated and what you delivered. So how do you at FlexGen think about that problem? And this is a bit of a layup to you, really. I don't know what your answer is going to be to this question, but how do you solve that problem? And how big of a problem is it? And can you get there? Can you get to the point where the asset owner or the optimizer says, I want 100 megawatts and you guys will make sure you get it?
Yeah, no, I mean, you've identified a very important point, right? And I think it's something that we're keenly aware of. It's not just availability, but it's having full capacity, full depth of discharge. And when you bid into a market with X, you're going to deliver X, not 80% of X, and take a penalty for not delivering. Right? You're absolutely right. And I think that this is done for us with our proprietary state of health and state of charge algorithms that we have that differ than from what was originally from the OEM. We can fine tune the ability to get the absolute most out of a system, right? I think one of the things that we identified is that like a lot of folks were just using their batteries between 20 and 80%, and they were leaving a lot of capacity on the table because when they would go outside of those, they might trip. And that was because they had inaccurate state of charge information from the OEM. Those OEM systems might be more conservative, and they would trip offline early because there would be imbalances or something like that. And I think that what we've focused on here at FlexGen is how do we get more out of those systems, and what we've done is to develop in-house to create a state of charge and state of health algorithm that allow us to understand exactly how that specific battery asset is performing, how it's been used in the past, how much it's degraded, and use that to give a very very specific to that installation a state of charge that allows you to have much more confidence and bid a larger margin of that total capacity that you expect to have into the market, get paid for it, and not come up short when you bid X and you want to hit 100% of X.
Yeah, absolutely. It's a massive problem.
It really is. It really is. And I think that it also includes quite a bit of collaboration with our life cycle services team within our remote operations center. They're experienced battery operators and understand and can sort of we need to operationalize the knowledge right within software so that it's easier for folks to have that in-depth battery operation knowledge. And so we're working to take what we have sort of institutionally and include it in our software such that it's easier for the folks who are operating these batteries to do it themselves, right? And sort of that's a real value proposition of the hybrid OS software system and a partnership with our lifecycle services team.
I just want to go back on something you said previously, because you said that Flexgen and your software is agnostic to the type of hardware, right? So you'll integrate with any battery type,
That's
which
correct.
sounds fantastic. And you use the Lenovo, you're using a Lenovo laptop and it runs Microsoft, and Microsoft is the example of it being hardware agnostic, which I kind of get, right?
Yeah.
And that sounds great. But I've got to ask you a couple of questions about it, because in practice, it's a lot more difficult. If we just use your example with Microsoft, for example, yes, they're hardware agnostic, but then for decades they relied on chips being in the x86 architecture, for example, not to get too niche here, but Intel chips. And I remember when Microsoft was available on AMD, when I was just a lad, I was kind of 9 or 10 years old building computers, and you could suddenly use Microsoft on XP or Windows 95 on AMD, and it changed the whole world. And my point is here, you can be hardware agnostic, but there needs to be some guardrails, right?
Of
Because there
course.
needs to be some sort of framework, because you could end up spending 90% of your R&D costs as a business on integrating with niche tier 4 suppliers, doing Modbus integrations over WeChat with all these language barriers or whatever. That's not me. There's no disrespect to China in that. It's just it's complicated stuff integrated with all these different battery manufacturers and inverter types and whatnot. So then my question to you is, how do you actually manage that in practice? Because I know that there's doing some of this work in my previous company. It can turn out to be quite the nightmare. How do you make sure that you don't spend 90% of your R&D cost integrating with these niche manufacturers?
Yeah, and I think you're right. I mean, we have a pretty as FlexGen, we have a very rigorous vendor selection process. We won't integrate just anybody who makes a battery, obviously, right? There need to be certain quality standards. There needs to be various common communication protocols and various things. Our technical team, our software team would be more capable of answering this question probably than I would. But I would say that we've spent a lot of time trying to figure out how to standardize that process. And that was one of the things that I mentioned earlier when we were talking about AI tools. When we have it's a tool that we have internally that we call config composer, and it's an internal tool that creates configurations that allows us to map between different OEMs. And that is what you've just described. It is extremely hard, right? And it's something that is absolutely very challenging. And FlexGen's job is to make that easier, right? And to standardize some of those workflows that go into creating those integrations. Because you're right, like in the past, they took an incredibly long time, and you could had a potential to make mistakes that would have catastrophic impacts within a system, and you'd have to go start fresh. But yeah, so I think it's two things. It's making sure that we have quality standards on the OEM side, but then also to standardize the approach to bringing those OEM pieces of equipment together in a way that makes sense and is done in a very standard way.
Yeah, if only everything was standardized.
That's what I'm saying, is that ultimately FlexGen wants to be that direction of stabilization, right? And like to be that thing that brings it all together in the middle. Yeah, you can't bring any battery, but FlexGen has now done probably 50 or 60 different configurations of DC block and AC block and balance of plant, and many, many different configurations, and even more have been mapped, right? But like with this config composer tool, we can accelerate that process and create additional configurations in the matrix between DC block and AC block and all of the different systems that we use. But yeah, you're right. It is an extreme challenge, and it's not an easy thing to do, and it's really sort of one of the key value drivers of the FlexGen value proposition.
Yeah, if you can crack that, there is enormous value. Some people know this, but when we started Motor Energy, we originally started a company to be an optimizer. So we wanted to trade power with software and get assets in the market and control assets. And one of the underlying assumptions about our business when we thought about this in 2018, 2019, was that in the near future, all of this was going to be possible via API, and that there would be some level of standardization, and that all the assets would have redundant, high bandwidth internet, right? And of course, you can do that with Starlink now, but it was a bit more difficult back then. I think that was one of the worst assumptions we could have made about the business, because even now, the limitations on what you can control via API are still massive and real. And so for a company like you to be able to break down some of those barriers, you can create a lot of value, you can get some really sticky customers, and ultimately you can get more different types of combinations of assets built,
Yeah.
which is a really good thing to do.
Yeah, no, I agree with you wholeheartedly, and I think that, you were probably maybe just a little early maybe in that assumption, because I think that that's where we would like to go as well, right? Ultimately, the FlexGen wants to be that EMS that operationally can enable those optimizers to connect via API. We have integrations with optimizers. We ourselves are not an optimizer. We kind of steer clear of that area. But yeah, our job is to make it so that the systems work when doesn't matter who, it doesn't matter what the communication protocol in, when they press the button, it does what it's supposed to do. It sounds really simple, and I'm really good at, saying that and making it sound somewhat simple, but the architecture behind it is incredibly complex and is why FlexGen has a pretty unique proposition in the market, I think.
Yeah, I'd love to see it in action.
Yeah, yeah. We'd love to have you to Durham, actually. Well, maybe we can bring you out and give you a tour of our innovation lab, where we bring different combinations of OEMs systems to kind of pre-integrate them in a laboratory setting. We've got a 1 gigawatt interconnection there, so we can push and pull power and do some pretty cool testing between the new DC blocks and inverter manufacturers. We can run those testing there and test the configurations that we've created in that config composer I was telling you about, and ultimately then kind of walk next door into the remote operations center and show you where we're monitoring. I think we've got 6 or 7 gigawatt hours of systems that are currently in operation and being monitored from that room, and much more to come.
Wow, huge numbers. Yeah, I'd love to come. Let's get it in the diary. That sounds like fun.
It does.
So you must talk to a lot of asset owners and developers and folks who are building assets. So when you're out in the market and you're speaking to folks who are building these assets, what are some rules of thumb or some guidance that you would give them when you're in conversations with them?
Of course, I'm biased based on our approach and our business model, but I think, as we were saying, like, fundamentally batteries are simple, right? They charge and they discharge. So because of that sort of simple notion, a lot of times folks get really pretty caught up on the capex decision and the selection of hardware, which OEM and who they're going to use. And I think that that is, of course, an important selection. You got to make sure you've got a bankable and a viable partner for the long term performance of your asset. But one thing that I think that gets overlooked is the software that's going to control those systems. And that's what I think is sort of a misconception, is that without intelligent and capable software running those systems, a DC block is just a shipping container with fundamentally, EV batteries wired in series in it. That's not going to do anything. So we think that many entering the industry need to pay a little bit more attention to that on the front end, and when we try to do market education to that effect. But yeah, I think that that's a pretty key component of how to be successful in this industry, is to think about that on the front end.
All right. I'm going to go to our last two questions now. So is there anything that you want to plug? You've got our audience's attention. Is there anything you want to talk about or announce? This is your chance. And then I'm going to ask you, what is your contrarian view?
In terms of what would I like to plug, I would say that I would like to have FlexGen be the energy management system of every battery storage system out there. I think that we've proven the ability to deliver very high availability for our customers, and I think that that's a unique differentiator for us here. And we would like to continue getting in front of as many folks as possible to tell that story. I think that one of the most exciting opportunities in the near term is going to be around data centers. Obviously, right? I think that people are very excited about the load growth that's coming there. It creates a lot of challenges, a lot of problems, but I think that battery storage as an industry is going to solve a lot of those problems, or at least be an important component of the solution in addressing those issues. And FlexGen will be right there to manage those for our data center and IPP customers that support those build outs.
And now your contrarian view. So what's the thing that you believe, Zach, that not a lot of other people do?
I think the batteries are going to save the world. No, I mean, I think at FlexGen, fundamentally, we think that access to power, reliable power, is really the foundation of modern human life, right? If we're going to be successful in many of the goals that we have, we need to have reliable power. And fundamentally, that's sort of at risk right now. I think a lot of things, in the modern world, so many of us take for granted. We flip that light switch and it comes on. And I think that we forget or don't know the complex system behind that light switch that is responsible for bringing that up to our homes and to our businesses every day. And most of that system was created somewhat haphazardly, and mostly, I think most of the grid now is built in the 60s and 70s, isn't approaching the end of its useful life, and there are significant changes that need to be made. And with the finally, after some stagnant growth in demand, we're going to see pretty significant growth there. And in order to meet those needs, we're going to have to make some significant changes. But luckily, I think that the problem or the challenge that we face there, at least in the short term, it's not a 24-hour problem, right? One of the things that we've been saying at Flexgen a lot recently is what we see, especially with the way that the demand curve works, is that, the challenge that we face, it is a 4-hour problem, not a 24-hour problem, right? We can do a lot of good by addressing a 4-hour period of time in every day. And I hesitate to say this because it brings me back to, COVID traumas, but we need to flatten the curve by taking some of that peak demand and shifting it using batteries. We can accelerate the deployment of all sorts of new generation, especially AI data center loads and additional manufacturing that we hope to build here and all over the world. But the first problems that we need to solve is to address that peak demand moment. And of course, as we grow, we're going to have to shift the whole curve up in parallel by adding generation. But I think that a lot of challenges can be addressed up front by solving that 4-hour problem. And we think that obviously 4-hour duration batteries with generation behind them are a uniquely capable tool to solve that 4-hour problem.
Okay, Zach, thank you very much for joining us on the podcast. It was a pleasure. And very much looking forward to the invite to come and see your testing lab.
Yeah, we'd love to have you in Durham.
Awesome. Thank you, Zach. Until next time.
All right, pleasure.